Yo guys, this is Cambridge IGCSE Chemistry May 2020 paper 43. Question 1, part 8. The structures of 5 organic compounds A, B, C, D, and E are shown. Answer the questions that follow. Each letter may be used once, more than once, or not at all. Compound A contains COOH, which means that it is the carboxylic acid. Compound B contains no other functional groups except C single bond C, so it's an alkane. Compound C has C double bond C, meaning that it's an alkene. Compound D has OH group over here, which shows that it's an alcohol. Then compound E has COH group again, so this is a carboxylic acid. Give the letter of the compound that is propan-1-O. OL here means that it's an alcohol and we only have one type of an alcohol. Also, prop here means there are 3 carbon atoms and compound D has 3 carbon atoms, so the answer is D. Give the letter of the compound that has the empirical formula of CH2. If it's CH2, it has no oxygen atoms, so we only consider from compound B and C, while compound B is C3H8 and compound C is C3H6, which can have the empirical formula of CH2. So the answer is C. Give the letter of one compound that reacts with bromine in an addition reaction. The one that reacts with bromine in an addition reaction is an alkene, and compound C is the only alkene that we have, so the answer is C. Give the letter of one compound that reacts with chlorine to form the compound shown. There's a chlorine atom here substituted to this, so it's something that can have a substitution reaction with chlorine in the presence of light, which is actually the photochemical reaction. The answer is an alkane. B. Give the letters of 2 compounds that can react with each other to form an ester. Well, ester is formed by a reaction between an alcohol and a carboxylic acid. So we have one alcohol here, compound D, and we have 2 carboxylic acids, compound A and E. You just have to write either one of them, so the answer can be D and A or D and E. Give the letter of the compound that is in the same homologous series as hex-1-ene. You just need to pay attention to the last 3 letters. It's an E and E, which means that it's an alkene. And the alkene in our diagram was compound C. So the answer is C. Give the letter of one compound that is an acid. Well, you can just tell it from the name. Carboxylic acids end with an acid at the end of their names. So the answer is either A or E. Draw a structural isomer of compound D. Show all of the atoms and all of the bonds. Compound D was an alcohol with the OH group at the side of the chain. So this time we can draw this OH group in the middle of the chain. Make sure you have the same number of carbon atoms and hydrogen atoms, and it's done. Part B. Some acids are described as weak acids. State the meaning of the term weak acid. So the word weak means that it does not fully ionize. So for strong acids, they will ionize completely, but for weak acids, they don't. Then the word acid means that it donates or loses protons. This is also a very common question, so make sure you memorize this. Ammonia is manufactured by the Haber process. Part A. The equation for the reaction is shown. N2 gas plus H2 gas produces NH3 ammonia gas. State what is meant by the symbol this. I'm sure you guys have seen this symbol a lot of times. It stands for the reversible reaction. State one source of hydrogen used in the manufacture of ammonia. Where do we get ammonia from? We get it from hydrocarbons reacting with steam. For nitrogen, they're just obtained from the air. Part B. The table shows some data for the production of ammonia. Deduce the effect on the percentage yield of ammonia of increasing the pressure of the reaction. To compare the data from the table, you have to look at something that has the same temperature, which is these two rows. So since these two have same temperature 450 degrees, and when the pressure was 180 m, the percentage yield was 28, but when the pressure increased to 400, the percentage yield became 42, so it increased. Therefore, the answer is when you increase the pressure, it increases the percentage yield. Next, increasing the temperature of the reaction. This time we compare the rows that have the same pressure, which are these two. When temperature was 350 degrees, the percentage yield was 58, but when the temperature was increased to 550, the percentage yield became 20, so the percentage yield decreased. For this question, you have to identify which rows to look at, and when you're comparing something, make sure the other variables stay constant. Part C. Explain in terms of particles what happens to the rate of this reaction when the temperature is increased. So this question comes out every time. Well, since they mentioned in terms of particles, you have to talk about the kinetic theory. Firstly, because the temperature is increased, the particles will have more energy. And if they have more energy, there will be more collisions per second, or you can say that there is a greater collision rate. As a result, more particles will start having energy higher than the activation energy, or higher rate of successful collisions, so the rate of reaction will be increased. Part D. Ammonia NH3 is used to produce nitric acid HNO3. This happens in a three-stage process. Stage 1 is the redox reaction. Identify what is oxidized in stage 1. Give a reason for your answer. Well, you say that a compound or an atom is oxidized if it gains oxygen atoms or its oxidation state is increased. Since NH3 became NO, it's obvious that it gained one oxygen atom. The substance oxidized is nitrogen, or you can say ammonia as well. And the reason is because it gained one oxygen, or you can compare their oxidation state. So for the oxidation state of nitrogen in NH3, since H3 is just plus 1, but 3 of them, so it's plus 3. The oxidation state of nitrogen in this case would have been negative 3. Then for the nitrogen atom in NO here, the oxidation state of oxygen is negative 2. So for nitrogen atom, it would have been plus 2. So you can see that it increased from negative 3 to plus 2. In this reaction, the predicted yield of NO is 512 grams. The actual yield is 384 grams. Calculate the percentage yield of NO in this reaction. To find the percentage yield, you divide the actual yield with the predicted yield, then multiply it by 100. You get 75%. The equation for the reaction in stage 2 is shown. Which major environmental problem does NO2 cause if it is released into the atmosphere? Well, nitrogen dioxide is a harmful gas because once it starts to react with rainwater, it's going to form nitric acid, and nitric acid is basically the acid rain. The equation for the reaction in stage 3 is shown. Calculate the volume of O2 gas at room temperature and pressure needed to produce 1,260 grams of HNO3. Use the following steps. Calculate the number of moles of HNO3. Since we know its mass, 1,260 grams, and we can find its molecular mass by referring to the periodic table. Well, for hydrogen, it's 1, so 1 plus nitrogen is 14, then for oxygen is 16, but we have 3 atoms, so 16 times 3 equals to 63. And the formula for this is number of moles equals to mass divided by the MR. So 1,260 divided by 63 equals to 20. So there were 20 moles of HNO3. Then deduce the number of moles of O2 that reacted. In this case, we just used the ratio. There were 4 HNO3 and just 1 O2. So the ratio is 4:1. And the number of moles of HNO3 was 20. So the number of moles of O2 will be 20 divided by 4, which is 5. Calculate the volume of O2 gas that reacts at room temperature and pressure. For the volume of gas at room temperature and pressure, we use this formula, which is number of moles equals to the volume of gas divided by 24. Since we know the number of moles, we've just found it here. To calculate the volume equals to 24 times the number of moles. So 24 times 5 equals to 120. So the answer is 120 dm cube of oxygen gas is needed to produce 1,260 grams of HNO3. Part E. The reaction in stage 3 is exothermic. Complete the energy level diagram for this reaction. Include an arrow that clearly shows the energy change during the reaction. Well, if it's an exothermic reaction, it releases heat, which means it releases energy, so the energy overall will decrease. The reactants are already here, so we need to write the product, which is 4HNO3, and that's gonna be above the product line. Now, since it's an energy level diagram, it needs to look like this. And then they said, include an arrow to show the energy change during the reaction. Well, that arrow should be here, right from the reactant's energy to the product's energy. Then don't forget to label your diagrams. So writing 4HNO3 here is 1 mark, and this product line lower than the reactant line is another mark, and the third mark is for this arrow and the label. Question 3. Chlorine is in group 7 of the periodic table. Part A. Two isotopes of chlorine are chlorine 35 and chlorine 37. State why these two isotopes of chlorine have the same chemical properties. Well, that is because chemical properties depend on the number of electrons. So since these are isotopes, only their number of neutrons will be different and the number of electrons will stay the same, so they will have the same electronic configuration and same chemical properties. Complete the table to show the number of electrons, neutrons, and protons in each atom and ion. So for chlorine 35, the number of electrons. Okay, the bottom number stands for the number of protons, and since it's a neutral atom, it doesn't have any charge. The number of electrons will also be 17, and the number of protons 17. Then the number of neutrons, well, the number on top stands for the number of protons plus the number of neutrons. So 35 minus 17 equals to 18. The answer is 18. Then for this, it's chlorine 37 and it has a negative charge here. While the number of protons remains the same, it's 17, but since it has one negative charge, the number of electrons will be 18. It just has one more electron than proton, so there is a negative charge there. And the number of neutrons, well, it's 37 minus 17 equals to 20. Part B. Chlorine reacts with aqueous sodium bromide. The equation for the reaction is shown. State the type of the reaction shown. Cl2 was here and Br was here, but one of the chlorine atoms suddenly went in here and Br was taken out like this. So this is the displacement reaction. Chlorine atom displaced the bromine atom. You can also say that it's a redox reaction. Why is there no reaction between iodine and sodium bromide? In order to have a reaction there, iodine will have to replace bromide and go inside here. But it can only happen if iodine is more reactive than bromine. But iodine is less reactive than bromine, so it cannot replace bromine. Part C. Magnesium reacts with chlorine to form magnesium chloride. Complete the dot and cross diagram to show the electron arrangement of the ions in magnesium chloride. Give the charges on the ions. The inner shells have been completed. Magnesium is in group 2. It has a proton number of 12. Then chlorine is in group 7. It has a proton number of 17. So initially, magnesium atom would have looked like this. 2 electrons in the first shell, then 8 electrons and 2 electrons again in the outer shell. Well, to be a stable atom, it will have given away its 2 outer electrons. So this 2 will be gone, and the magnesium ion that we need to draw will only have 2 electrons in its inner shell and 8 outer electrons. It will have a charge of 2 plus. Then for chlorine atom, it would have looked like this. 2 electrons, 8 electrons, and 7 electrons in its outer shell. Well, in order to be stable, it would have had to gain 1 electron from some other source, probably the magnesium ion over here. So it has added 1 more electron. Therefore, we draw 8 outer electrons for chlorine atom, but make sure that one of its electrons is put as a cross to indicate that it has come from the magnesium ion. Also, since it has gained 1 electron, its charge will be 1 minus. Part D. Hydrogen and chlorine react to form hydrogen chloride gas as shown in the equation. H2 plus Cl2 gives 2HCl. This equation can be represented as shown. Some bond energies are shown in the table. Calculate the energy change for the reaction between hydrogen and chloride using the following steps. Calculate the energy needed to break the bonds. Well, in our question, there are just 3 bonds. And obviously, you'll have to break every single bond here and form every single bond here because you need to break this and then form this. We're breaking these 2 bonds, so 436 plus 243 equals to 679. Calculate the energy released when bonds are formed. There is only 1 bond formed here. You don't even have to be confused. HCl, literally 432, but you have number 2 in front here. Well, they won't give you a question that don't even require you to do some calculations. Always be careful. It's going to be 2 times 432 equals to 864. Then calculate the energy change for the reaction. To calculate the energy change, it's the energy needed to break the bonds minus the energy released when bonds are formed. 679 minus 864 equals to negative 185. It's extremely important that you put this negative sign here. Question 4, Part A. Filtration and chlorination are 2 stages in water treatment. State the purpose of each stage. Filtration, just think about a filter paper. They remove solids from water, and that's exactly what you need to write for this. Then chlorination, it's simple as well. They sterilize the water, or you can also say it kills the microbes or prevent illness. But sterilization is good enough. Part B. A student uses anhydrous copper 2 sulfate to test for the presence of water. What color change is seen if water is present? Since it was an anhydrous copper 2 sulfate, initially it will be white. Then in the presence of water, this will be hydrated and it will turn to blue. The purity of a sample of water can be assessed by measuring its boiling point. How is the boiling point of water affected by impurities? For water, the boiling point is 100 degrees Celsius, but if there's any impurities, the boiling point will be higher, so it can be 102 degrees or 105 degrees and so on. Part C. Chromatography can be used to test the purity of a substance. The diagram shows the chromatogram of a colored substance. We see 2 dots over here. How does this chromatogram show that this substance is not pure? If a substance is pure and you carry out chromatography, you'll only see 1 dot. However, right now we have 2 spots, so it shows that the substance is not pure. Draw a circle around the correct RF value for the spot labeled X. To find the RF value, we need to take 2 measurements from the chromatography paper. One is the distance between the solvent front and the start line. I got around 4.4 centimeters. I'm not sure how accurate this is because I'm measuring this off from my screen, but our final answer will be the same, so it's fine. Then next you have to measure the distance the spot has traveled from the start line, which is this. And I got 3.6 cm. Then after that, you try to find the proportion of the distance that X has traveled, so 3.6 divided by 4.4. If I round this up to 1 decimal place, I get 0.8. The answer is 0.8, and you should be getting this as well. State how a colorless substance can be made visible on a chromatogram. This method is used when we want to carry out chromatography for amino acids. We need to use a locating agent. But don't write that we need to use ninhydrin. It's not included in the mark scheme. You have to say use a locating agent. Question 5, Part A. Complete a table about solids, liquids, and gases. Right, this is the first chapter of chemistry. While solids, the particle separation, they are touching, just like liquid. Then the particle arrangement for liquid, they're not like solid, they're not regular, but they're rather random. Then the type of motion of gas, they do not vibrate only, while liquid, it's random, which is the same for gas. Part B. The graph shows the change in temperature as a sample of gas is cooled. Name the change of state taking place between A and B. They stated that it's a gas, so gas over here. Then obviously the next point here will be liquid. Then solid here. So from gas to liquid, it's condensing. Part C. A bottle of liquid perfume is left open at the front of a room. After some time, the perfume is smelled at the back of the room. Name the two physical processes taking place. First, we need to take note that it's a liquid perfume, and for it to be smelled in air, there should be evaporation happening. So the first physical property is evaporation. Then the next thing to take note that it was opened at the front of the room, but it was smelled at the back of the room, which means that it has traveled across the room and diffusion has occurred. Question 6, Part A. An endothermic reaction occurs when calcium nitrate is heated. Balance the equation for this reaction. Firstly, calcium looks fine. Then nitrogen, we have 2 here, and we only have 1 here. And for oxygen, we have 6 and 5 in total over here. Well, let's first try to have 6 oxygen atoms on the right hand side. Then we have to put 2 in front to have 2 oxygen atoms over here. Then since we'll have 2 calcium atoms, we need to put 2 in front over here, so that calcium will also be 2 on the left hand side. And then now we have 4 nitrogen atoms, but we currently just have 1 here, so we'll have to put 4 in front of NO2 to make it 4 nitrogen atoms on the right hand side. Okay, but after doing all this, we now have 12 oxygen atoms on the left hand side, and for the right hand side, we have 2 here, 8 here, and 2 here, which makes it 12. And it's perfect, so the blank space here can be just put as 1. State the type of reaction shown by the equation. It's an endothermic reaction. Calcium nitrate is heated, and you can see that different products have been produced. This is a typical thermal decomposition. Part B. Describe the test for a nitrate ion. Yes, you have to memorize all the tests, not just for paper 6, but paper 4 as well, also for paper 2. For this, you have to add aqueous sodium hydroxide first, and then add aluminum foil and warm the solution. As a result, if nitrate ion is present, ammonia gas will be produced, and that's gonna turn damp red litmus paper to blue. Question 7. Aluminum is extracted by electrolysis. Iron is extracted from its ore by reduction with carbon. Part A. What is meant by the term electrolysis? Extremely important definition here that you should know. It's the breakdown of a molten or aqueous ionic compound by the passage of electricity. Part B. Name the main ore of aluminium. It's called bauxite. Part C. Explain why aluminium cannot be extracted by reduction with carbon. You can extract iron by reduction with carbon, but not aluminium because aluminium is more reactive than carbon and carbon cannot displace aluminium. Describe the role of cryolite in the extraction of aluminium by electrolysis. Well, we use aluminium oxide in the beginning of the electrolysis to produce aluminium, and we need to use cryolite because aluminium oxide has a very high melting point, and cryolite helps to lower the melting point so that we won't have to use so much energy to produce the molten state. Name the product formed at the positive electrode. Well, like I just said, we use aluminium oxide in this electrolysis. It's Al2O3, so we have Al3 plus ions and O2 minus ions involved in this electrolysis. Well, if it's a positive electrode, it's gonna attract the negative ions. And the negative ion from this is O2 minus. And it's the product formed, so from O2 minus ions, oxygen will be formed, and our answer is oxygen. Write the ionic half equation for the reaction at the negative electrode. This time it's the negative electrode, it attracts the positive ions, which is basically Al3+. So firstly, you'll have Al3+ ions. Then to make it as a stable atom, it will gain 3 electrons and form aluminium atom. And this is the complete ionic half equation. Part D. Aluminium is used in overhead electricity cables. Give the properties of aluminium that make it suitable for use in overhead electricity cables. Firstly, we all know that aluminium is very light. It has low density and it doesn't weigh much, so it can be used as overhead cables. Then secondly, it conducts electricity very well, so it can be used as an electricity cable. You can also say that it's ductile or malleable, so it can be easily formed in a cable shape. And it also has a protective oxide layer, so it does not corrode easily. Part D. Iron is a transition element. Iron forms hydrated iron trioxide when it rusts. Write a word equation to represent the formation of rust. It can feel like the question didn't give us any kind of information at all. Well, you have to know that for a substance to rust, they need two things. First one is water, and second one is oxygen, air. So for iron to rust, to become hydrated iron trioxide, it will have to react with water and oxygen. And since you're just writing a word equation, you can write iron plus water plus oxygen gives iron trioxide. And that's it. But of course, you have to keep this in mind. Give the ways in which the properties of transition elements differ from the properties of group 1 metals. It's good to think of an example. So for transition elements, let's think about copper. And group 1 metal, we can think of sodium. Now the first distinct difference is that copper has a higher density than sodium. So copper is much heavier than sodium, and it's harder and more resistant to force. The next thing is copper can form colored compounds. So it can be blue, green, and so on, but for sodium, they're just white. And also a very distinct feature is that copper has several oxidation numbers such as +2, +3, but for sodium, it's just +1. Well, other than these points, we have that transition elements act as catalysts and they have higher melting points. Question 8 Part A. Part of the synthetic polymer nylon is shown in the diagram. Circle 1 imide linkage on the diagram. It's the linkage, probably the one that connects the gray box and the white box. So it's this one. But you should really know that amide linkage is C double bond O and NH bond. Complete the structures of the two monomers that react to form nylon. Alright, monomers, they have given us the hint that the middle part is these boxes. Well, since monomers are repeated in polymers, so they should look like this, and another one like this. But you have to know that for amide linkage to be formed, water is produced as a byproduct. So these three atoms should be fitting in somewhere. For the gray box, we have C and double bond O here. There should be OH in each side, and it's complete. So be careful not to forget that water is also produced. Then for the white box, NH and just one hydrogen atom belongs here, like this. You should really memorize about the amide linkage and the monomers, the polymer and nylon, because it's quite a popular topic. And there aren't that many polymers that you need to know about. Name the other product formed when nylon is produced. I just said it, it's water. Part B. Items made of nylon are often disposed of by burying them in the ground. This is called landfill. Why is the disposal of nylon using a landfill a problem? It's a huge problem because nylon is a non-biodegradable substance, which means it's just gonna be there forever and ever. And if that continues, we won't have enough space for any more waste products to be stored. So it's really a problem that the world needs to focus. Part C, give the name of a natural polymer. So natural polymer is something that exists in nature without the interference of human technology and so on. There can be two answers, either carbohydrate or protein. That's the end of this video. I hope you guys learned something after watching this video. Please leave a like and comment to support me and if you want me to keep going. Thank you for watching. Stay safe. God bless you guys. Bye.